What are the philosophical implications of quantum mechanics? Imagine a universe where particles can be in two places at once, where observing something can change what it is, and where distant objects instantly influence each other. This is not science fiction but the reality revealed by quantum mechanics. This scientific revolution of the 20th century challenged many ideas about how the universe works. It made scientists and philosophers rethink what it means for something to be real, how we know things, and how cause and effect operate. At the heart of quantum mechanics are particles so tiny that they behave very differently from larger objects. They can exist in multiple states at the same time, a phenomenon called superposition. When we measure them, they seem to choose one state, but questions remain about whether these superpositions are real or just mathematical tools. This forces us to ask if reality is fixed or if it depends on observation. Another big puzzle is the measurement problem. When we look at a quantum system, it suddenly collapses from many possibilities into one outcome. This suggests that the act of observing plays a role in shaping reality. It challenges the idea that the universe exists independently of us. Instead, it hints that our observations might influence what actually happens. Quantum entanglement adds another layer of mystery. When two particles become entangled, measuring one instantly tells us about the other, no matter how far apart they are. This seems to break the usual rules of cause and effect and suggests that the universe is more interconnected than we thought. It raises questions about how space and time work at the most fundamental level. Different interpretations of quantum mechanics try to explain these strange phenomena. The Copenhagen interpretation says that particles do not have definite states until measured. The many worlds interpretation suggests that all possible outcomes happen in separate, parallel universes. These ideas challenge traditional views of reality and raise questions about whether the universe is deterministic or fundamentally probabilistic. Quantum mechanics also makes us rethink causation. It hints that some properties might not be fully reducible to smaller parts. Instead, higher-level features could have their own causal powers, which changes how we see the relationship between parts and the whole. Throughout history, this quantum revolution has changed not just physics but also philosophy. It has pushed us to reconsider long-held beliefs about what is real and how we come to know it. It has led to technological innovations like quantum computing and quantum cryptography, which relying on these strange quantum effects. In the end, quantum mechanics challenges our most basic assumptions about the universe. It introduces ideas like superposition, entanglement, and observer dependence that continue to influence how we think about reality. These shifts have reshaped philosophical questions and opened new paths for scientific discovery. They reminded us that the universe is more mysterious and interconnected than we ever imagined.